We want to derive this formula, and this formula gives us the angle of rotation of a conic section if it has been rotated. And the strategy is going to be to use the rotation formulas, which I won't derive those. They're all over the internet. This is fairly easy to derive and pretty common. But if you rotate a conic section, you will get always an xy term. I'll illustrate just real quickly with a parabola. So with conic sections, we have parabolas, ellipses, and hyperbolas. Well, if you substitute these into the just a parabola, I'm just going to look at the x part here. I just want to illustrate that when you square these things, the rotation formulas, well, if you do this, you'd get x squared cosine squared theta, and you'd get minus 2xy sine theta cos theta. And I'm not going to worry about the last one. I just basically wanted to quickly show you that you will always get an xy term when you square these things. And of course, conics are quadratics, and they will be squaring these, and so that this term would materialize. And so the strategy is to take this is the most general term of a conic equation. A lot of times you won't see this term because rotation is not relevant, but to be the most general possible, this term is included in case we were dealing with rotated uh, conic sections. And so the strategy is going to be to put these into here. All the x's and y's are going to have those substituted in. So I'm going to go ahead and start here, and I've already got it done. So for instance, the a squared term is right here, and I put that in there. And you'll notice every place where there's an x, then we have I have this substituted in there, and every place there's a y, this is in there. So basically, if you just do the algebra and simplify, then um, you'll get where we need to go. You can see here that this here is squared. It's just this, and this multiplies to this. This squared is this, and the D, E, and F, I have them in here, but I'm not concerned with because we're really only going to need A, B, and C. Those are the only ones that are going to end up contributing to the XY coefficient. And so if I go ahead and distribute the A into these three terms, I'm going to get this. And same with the B, there's four terms. And so that B is in each of the four terms here. And same with the C. And one thing I've done here is I moved all of the XY stuff to the far right of every term so that we can consider anything in front of those, the coefficients. And now all we care about are the coefficients of XY. And those I moved down here. So we don't care about anything else right now. We're basically going to figure out the coefficient of the xy term as we simplify things. And so for these two terms, I just pulled c minus a out front, and basically I'm factoring this out of both terms. And then for these two terms, I just pulled the b out front, pulled the xy out in back, and we have this expression in parentheses. And now we can use trig identities. You can find these on any trig identity sheet. So 2 sine cos is equal to 2 sine of theta, and cos squared minus sine squared is equal to cosine of 2 theta. And now if we factor this out on the right side, we end up having a coefficient for the xy term. And what we want to know is what would make that, what angle would make that equal 0. Because if the xy term disappears, your rotation is gone. And so basically, this theta ends up being the angle that it had been rotated by. And so to finish up here, we just take this coefficient, set it equal to 0, and solve. The way we solve is we divide everything by cosine of 2 theta so that we can turn this into tangent of 2 theta and this into a 1. And this continues being 0, of course, so that gets us to here. If I subtract b from both sides and divide both sides by c minus a, we get this, and this is basically it, except it looks nicer if we just flip all the signs of every term in the fraction, which is can be done with fractions. So I'm assuming that you know that, and so this basically is the formula. But if we solve for theta with tangent inverse, then we end up getting this. So either one of these are the formulas. So if you want to know how much a conic was rotated, basically all you're going to do is take these 3 coefficients and put them in here and then solve for theta, and you'll know the angle of rotation.